Hello Year 5 and welcome back after your half term. Welcome to another Monday Maths lesson, and today we're looking at reading scales with 2, 4, 5 and 10 part intervals. So you've got two numbers to look at first of all. You've got 100 and you've got 1,000, and I hope you can see that those numbers are being split into a number of equal parts. So I want you to divide each number into two equal parts and then say the value of each part. So think about what 100 divided into two equal parts would be. What would each part be? Pause the video now and have a go. Okay, so let's go through. So hopefully with 100, you knew that 100 divided by 2 was 50. 50 and 50 makes 100. Now let's look at 1,000. So 1,000 divided by 2 is 500. So we've got 500, add 500 to make 1,000. Okay, let's look at 100 divided into 4 equal parts. So what would I need 4 of? I would need 4 25s, and I could count in 25s to check. So 25 would take me up to here. If I added another 25, that would take me up to here. So that would be halfway, that would be 50. If I added another 25, that would be 75, and then a final 25 would take me to the end of my bar, 100. Okay. What about 1,000? Okay, 1,000 divided by 4, we would have 250 in each part. So 250, we'd have 500, 750, 1,000. You might want to join in with the counting. Counting is a really good skill to have. You could always go back and join in with me. Let's carry on. So 100 divided into 5 equal parts. So hopefully you thought about 20 in each part, because if we count in 20s, we should get to 100. So count with me this time: 20, 40, 60, 80, 100. Okay. It's interesting because 10 divided by 5 would be 2, wouldn't it? 2, 4, 6, 8, 10. So let's think about the patterns that we notice as we go through. What about 1,000 divided by 5? So hopefully you knew that we would need 200s. 200, 400, 600, 800, 1,000. Now let's do 100 divided into 10 equal parts. So I know that 10 lots of 10 make 100. So I can count in tens. Count with me. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Super. I could count in tens. I could say 10 tens, couldn't I? But we know 10 tens is 100. Let's divide 1,000 into 10 equal groups. So we should have 100 in each group. And again, I could count in hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900. I could say 1000, but we know 10 hundreds is the same as 1,000. So what did you notice? Pause the video now and have a think about that if you haven't already had a think about this. Okay, so I hope you can see that whenever we divide a multiple of 10, so 100 or 1,000 by 2, we always end up with a 5, don't we? Because 5 and 5 makes 10. Whenever we're looking at dividing by 4, and we've got 100 or 1,000, we always have that 25, don't we? 25. Whenever we're dividing into 5 equal parts, we always end up with 2s. And whenever we're dividing into 10 equal parts, we end up with 10 or a 1. So that's an interesting pattern. You're going to benefit from remembering that, from thinking about that as we go through. So if you want to stop the video now and practice counting, just to embed that, please do. Otherwise, let's move on, because I want us to look at what would happen if we divided 1 into these parts. Okay, so just 1, so thinking about 1 whole. So we need to think about our decimals here. And I know that you did really well in your decimals work just before Christmas. So try and think back to what 1 whole would be made of. What are the decimals? So if we divide 1 into 2 equal parts, what would the value of each part be? Well, I know that 1 whole is made up of tenths. And I know that 1 whole is the same as 10, write it like this, 10 tenths. And I know that I would write each tenth like this, 0.1, okay? So if I think about 1 whole as 10 tenths, and I divide my 10 tenths into 2 equal groups, I would be left with 5 tenths, wouldn't I? So 5 tenths on this side and 5 tenths on this side. 5 tenths and 5 tenths makes 1 whole, or 10 tenths. Now let's think about it. What about if we divide our 1 into 4 equal parts? Now for this one, I need to also remember that 1 whole it can be split into smaller parts than tenths. It can be split into hundredths. So how many hundredths makes a whole? Can you remember? It is 100 hundredths. And our hundredths have 2 decimal places, 0.01. Okay, and our hundredths can be equivalent to tenths, can't they? So when I divide 100 into 4 equal groups, I ended up with 25, didn't I? So if I divide 100 hundredths into 4 equal groups, I will have 25 hundredths in each group. So let me write them down. 25 hundredths, 25 hundredths, and 25 hundredths. Okay. Now let's think about dividing our whole into 5 equal parts. So I could think about my tenths for this, couldn't I? Because I can divide 10 by 5. I know that 10 tenths divided into 5 equal groups would be 2 tenths in each group. So I'll write my 2 tenths. 2 tenths, 4 tenths, 6 tenths, 8 tenths, and this would be 10 tenths, or 1 whole. Can you see how I'm counting them there? Now this one is quite easy based on what we've spoken about already, isn't it? If I just move this down, we already know that 1 whole is made of 10 tenths. So if my whole is divided into 10 equal parts, then each part must be worth 1 tenth. So 1 tenth. And I could fill them all in, couldn't I? 1 tenth. I think you can see where I'm going with this. So you can pause the video and fill them in now. Now it's really important for us to be able to count in these groups. So we're going to spend the next part of the lesson practicing counting in these different multiples, in these different parts, and we're going to count backwards and forwards. So I want to hear you counting along with me, okay? Whenever I say we're about to count, or if I nod, you know, just take the cues and count along with me. I'm going to switch to a PowerPoint now because it will be easier for us to do our counting from this. So I'm going to show you some bar models where our whole is 1, and I want you to think about how many parts has the whole been split into. So what do you think we need to count in? How do you know? So here's the first bar model. How many parts has it been split into? So whenever I'm asking a question now, you need to answer. Okay, so what do you think we need to count in if our whole has been split into 4 equal parts? Remember that 1 whole is 100 hundredths, and 100 divided by 4 is 25 hundredths. So I can fill it in, 25 hundredths, 25 hundredths, 25 hundredths, 25 hundredths. But we wouldn't count it like that, would we? When we were counting our 25s before, we added on, didn't we? 25, 50, 75, 100. So let's count by adding on our 25 hundredths. So 25 hundredths, 5 tenths, 75 hundredths, 1. Oh, were you expecting to count that way? Let's look at this sequence and why it works. You might want to think, why don't we say 50 hundredths? Can you remember? Well, I hope you remembered that 50 hundredths is the same as 5 tenths. So we don't need to put that 0 on because 50 hundredths is the same as 5 tenths. It's more accurate to write 5 tenths. So if we have 25 hundredths and we add another 25 hundredths, we would have 50 hundredths, wouldn't we? But we write that as 0.5 and we read it as 5 tenths. Then if I added another 25 hundredths, it would get me to 75 hundredths. And then 4 lots of 25 hundredths would be 100 hundredths, which is a whole. So let's count one more time, okay? Count with me. Here we go. 25 hundredths, 5 tenths, 75 hundredths, 1 whole. Let's count it just as decimals as well, okay? 0.25, 0.5, 0.75, 1. So we've got to get really used to counting in those ways. Why do we say 1 and not 0.100? Have a think about that. Well, we've already kind of discussed this, haven't we? Remember that 1 whole is the same as 100 hundredths. Okay, so we would need to regroup our 1 into the 1's column, wouldn't we? Okay, let's have a look at some more bar models. So remember, what's it been divided into? What will we need to count in? Okay, have a look at this one. So our whole has been divided into 10 equal parts, so we need to count in tenths. Count with me in tenths. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 1 whole. Okay, I could say 10 tenths, but let's say 1 whole because that's what we're showing here. Let's look at the next one. So what's our whole been split into this time? What will we need to count in? Okay, so hopefully you can see we've got one line dividing up. So one line dividing up means we get 2 spaces, doesn't it? So we should be counting in groups of 5 tenths. So 5 tenths and 1 whole, because 5 tenths and 5 tenths makes 1 whole, doesn't it? Okay, what's it been divided into this time and what will we count in? Okay, so this time it's been divided into 5 equal parts. So remember, 10 tenths divided by 5 into 5 groups would be 2 tenths. So we're going to count in 2 tenths. Okay, count with me. 2 tenths, 4 tenths, 6 tenths, 8 tenths, 10 tenths, or 1 whole. We could also count in decimals, couldn't we? So count with me in decimals. 0.2, 0.4, 0.6, 0.8, and 1 whole. Okay. Now let's move on because I want to show you this in a slightly different way, because sometimes you might need to count in these intervals, but you won't have a bar model, okay? You'll have a number line instead. So let's count in steps of 5 tenths, here it is, from 0, there's 0, all the way up to 1. Now let's look, we've got one line on here, haven't we? So does that mean our whole has been divided into 1 equal group? No, I can see that I've got an equal space on each side of that line. So we've got 2 equal groups, haven't we? So 1 mark means 2 equal groups. Okay, so if we counted in steps of 5 tenths from 0 to 1, we would count, you can count with me, 0, 5 tenths, 1. Okay, 0, 5 tenths, 1. Now let's count in steps of 25 hundredths, 2 tenths, and 1 tenth. Okay, we'll do this in separate number lines. And can we count backwards from each of these as well? Okay, so here we go. Here's our 1 now, and it's been divided into 1, 2, 3, 4 equal spaces. So what are we going to count in steps of this time? It's going to be our 25 hundredths this time, isn't it? Okay, so count with me from 0. 0, 25 hundredths, 5 tenths, 75 hundredths, 1 whole. Let's count backwards. 1 whole, 75 hundredths, 5 tenths, 25 hundredths, 0. We could count in decimals, so count forward in decimals. 0, 0.25, 0.5, 0.75, 1. Now you count backwards and pause the video. Okay, now let's count in these steps. So what's our whole been divided into this time? 1, 2, 3, 4. I've got 4 lines. Does it mean it's been divided into 4? Well, remember that 4 lines means I end up with 1, 2, 3, 4, 5 spaces, okay? So 5 equal parts is what we would need, because I've got 1 part here, then I'd need to add another part, 3 parts, 4 parts, 5 parts, okay? So we're going to need to count in 2 tenths this time. So count with me from 0 in 2 tenths. 0, 2 tenths, 4 tenths, 6 tenths, 8 tenths, 1. Let's count backwards. 1, 8 tenths, 6 tenths, 4 tenths, 2 tenths, 0. It's a bit like counting in 2s, isn't it? And last but not least, what has our whole been split into this time? Now remember, there are 9 lines, but that means there are 10 spaces, 10 equal parts, okay? So we're going to count in tenths. So count in tenths from 0. 0, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 1 whole, or 10 tenths. Let's count backwards. 1 whole, 9 tenths, 8 tenths, 7 tenths, 6 tenths, 5 tenths, 4 tenths, 3 tenths, 2 tenths, 1 tenth, 0. You might want to practice that. Okay, we can practice counting from different places now, different parts, because if I count in steps of 2 tenths, what comes after 0.4 but before 1? So after 0.4 means bigger than 0.4, before 1 means smaller than 1. So I need to look at what is between 0.4 and 1, and it would be 6 tenths and 8 tenths. What about this one? If I count in steps of 1 tenth, what comes between 0.4 and 0.6? See if you can answer that question. Okay, so if I'm counting in steps of 1 tenth, and I go from 4/10 to 6/10, that's our even tenths. There's an odd tenth in between, it's 5/10. Okay, now I want you to look at these number lines and tell me what's different about these number lines. Okay, hopefully you noticed that we've now got different units, okay? We've still got a difference of 1, okay? But we're counting it from different places because we won't always count from 0, will we? So we've got to think still about what our wholes have been divided into and what we will need to count in to find out what's in between them. Okay, so I'm showing you a red arrow on this first number line, and I want us to think about what the value of that interval would be, what the value of that line would be. So this is how I want us to think about it. Is the number before or after 3? And how do you know? Well, I can see that 3 is at the bottom and it goes up to 4. So this must be the number that we're looking at is between 3 and 4, but it comes after 3. Now think about why it comes after 3. It's because 3 is the lower number, isn't it? Okay, after 3, but before 4. So I want you to use that number sentence for the other number lines, okay? I'm going to put on some other arrows now. So can you see my arrows? So have a think about the arrows. Fill in the blanks. The number is between, but comes after. So that will help us know which unit we're going to choose, okay? Good. Now, if you pause the video and have a go at that, now I want us to do something different next. Okay, so now that we have thought about where our numbers are, we know that they're after 3, after 9, after 6, and after 1. We need to think about how many intervals there are on each number line so that we can decide what we're going to count in, okay? So even though there's one line, go through now, pause the video and think about what we would need to count in. Think about what each one has been divided into. Okay, now we can check where we think what the value of the different arrows is by counting from our lower multiple, okay? Our lower multiple of 1. So hopefully you thought that because we've got 2 equal groups, we were counting in groups of 5/10. So we would need to count 3, 3 and 5/10, 4. Now that would work, wouldn't it? Okay. So let's repeat for this one. So this time our whole has been split into 4 equal groups. So hopefully you are thinking about 25 hundredths, okay? So let's count from the bottom this time. 9, 9.25, 9.5, 9.75, 10. Okay, hopefully you can see how we can still have that 25, 5 and 75 pattern, even though we've got different ones, okay, different units. Now let's look at the next one. The whole has been split into 5 equal groups. So we will need to count in 2/10. But we're going to start from 6 this time, aren't we? So let's count together in tenths. 6, 6 and 2/10, 6 and 4/10, 6 and 6/10, 6 and 8/10, 7. So those numbers fit, don't they? So we can see where our arrow is. And for the last one, our whole has been split into 10 equal groups. So hopefully you realise we need to count in tenths, but we're not counting from 0, we're counting from 1. So let's count in tenths from 1. 1, 1 and 1/10, 1 and 2/10, 1 and 3/10, 1 and 4/10, 1 and 5/10, 1 and 6/10, 1 and 7/10, 1 and 8/10, 1 and 9/10, 2. And we can see where our arrow is. Okay, now I'm going to go back to the flip chart just to show you the last question, okay? So here we go. Have a look at the picture. What's shown in this picture or this image? What would you use this for? When have you seen this before? You might want to pause the video now and have a think about the question. Okay, so hopefully you recognise that this is a measuring jug. So we'd use it to measure liquids, wouldn't we? There could be juice or water or something in here. Now, it says, what do we notice about the scale? How many intervals are there between the 2 given values? So we can see that we're counting in ones. Okay, we've got 1 litre and 2 litres, but we need to think about how many, what that whole has been divided into, how many intervals there are between. So I can see that there are 10 equal spaces, okay, for every one. And we've got that 5, the 5th one is a bit longer, isn't it? It says, why is 0 not written on the scale? Where would it be recorded? So if this is 2 and this is 1, I would need to go right to the bottom, right to where it starts from, okay, from the very beginning of that line. because then I could count in tenths and it would make sense. This would be 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 1 whole. Now it says 1.6 litres of water is to be poured into the measuring container. At what interval on the scale would it reach? So pause the video now if you haven't done this, because I'm about to reveal it. So here it is. And we can see that we've got 1 whole litre and then 6 tenths. Okay, you might want to pause the video and repeat for some other volumes of water. See if you can choose another mark and read what value that would have. Okay, now is time for your guided practice. So pause the video and have a think about completing these different tasks, and then we'll mark them through together. Okay, how did you get on? So let's complete the bar models together. Hopefully you recognize these from before. So I'm just going to show it like this. Hopefully you have the same as me. Okay, super. Now we've got some sequences, and this is a little bit like our number lines where the spaces can be a bit misleading. So you've got to think about the information that you are given, okay? There's 1 gap between our 3 and our 4. So that's a little bit like when we had our number line and we had 3 at the bottom and 4 at the top. And we had 1 mark, didn't we? But that actually split our bar, our line, into 2 bars. If I just show you, we had an equal bar there and then an equal part here. Okay, so 2 bars, 2 equal parts. So we've got to think, okay, the whole has been split into 2 equal parts, so it would need to be counting in 5s, wouldn't it? 5 tenths. I wonder if you figured out the other ones. So let me reveal them now. Okay, so hopefully, let me just reveal these ones as well. Hopefully it will fit in a second. Ooh, I'm going the wrong way. There we go. Okay. So if you are a bit stuck with that one, perhaps think about how you can convert the sequence, the numbers, into a number line, and think about each missing box as a line. Okay. Now for this one, it's looking at the table, thinking about where have you seen this kind of representation before? So hopefully when you've been doing data and reading tables. But it's a bit different this time because we've got a scale counting in 2s with lots of intervals, equal intervals in between. So we've got to think about what each one of these intervals would be worth. Could it be worth 0.1? Could it be worth 1 tenth? Well, I don't think so. What did you think? Well, if we counted in tenths from 0, we would not meet 1, would we? So let's do it together just to check, okay? 0, 1 tenth, 2 tenths, 3 tenths, 4 tenths. So we know it can't be 10 tenths. So we've got to think, okay, it's 1 whole split into 1, 2, 3, 4 equal parts. And so we know that we need to be counting in 25 hundredths. And I'll just reveal the different values because we've probably already looked at this. So there we go. Hopefully you have something similar. Okay. Now it says here, what's the difference in the height of Joe and Bill's sunflowers? Is there a way to do it without having to subtract? So yes, there is. Hopefully you realise that you could just count the divisions of 25 hundredths. So if I compare Joe and Bill's bar, there's Joe's bar, there's Bill's bar. I'll move along because Bill's is higher. So Joe's would meet about there, wouldn't it? So I can count in 25s now. That'd be 25 hundredths, 5 tenths, 75 hundredths. So we can see that Bill's sunflower is 75 hundredths of a metre taller. Okay, now you've got some time for some independent practice tasks. There are 4 independent practice tasks. No, there aren't, there are 5, sorry. And then there are some deeper thinking tasks as well. And the answers are at the end, so remember not to skip ahead. I hope that's been a useful recap to you of decimals, and I hope this is going to be useful as we move forward when we're looking at measure for the rest of the week. Send your work into year 5 as always, and I'll see you next time, guys. Bye.